Our first ever, and maybe hopefully not our last ever, look back or special. This is a special edition of Space Fan News, where the end of the year we're going to take a look at some of the amazing astronomy stories that we've seen that have happened over 2013. Talk a little bit about what our favorites were, and kind of get some different perspectives on what's happened over the past year. This is a bit of an experiment in the sense that this is happening as a YouTube live event. This is my first ever YouTube live event on the Deep Astronomy channel, so I'm hoping that you guys will like this and respond well. With me today is a lot of some of my best friends and some really good colleagues. With me today is Dr. I'll go from left to right on my.
This left.
Are you hearing your own feed?
Yes.
Because you're waiting for it to count down. You're so vain. You probably think this video is about you.
Sorry about that. Technical issue. I'm going to leave Alberto up with his tongue hanging out. Okay, sorry about that. I was listening to my feed kicked in, and I'm listening to myself going, no, stop that. Okay, so with me is Alberto Conti, Dr. Alberto Conti from Northrop Grumman, my old friend, formerly of the Space Telescope Science Institute. Welcome, Alberto.
Thank you, Tony. It's really nice to be back here. I missed you guys. I've not been doing hangouts with you for like over a month and a half, or maybe two. So
I know it's great. I hope you do withdrawals because you need to start doing more of them. We miss you. We miss having you here. So welcome.
Thank you very much.
Also is Brian Koberlein from the Rochester Institute of Technology. He's a professor there. Welcome, Brian.
Thank you. It's my first time, so it's nice to be here.
Yeah, it's good. Well, it's a great. You're welcome to here, and we hope to see you some more in the future as well. Also, Fraser Cain. You guys recognize him from the Virtual Star Party, and he runs Universe Today. Hi, Fraser. Welcome. It's great to have you, and I don't get to do these very much with you, so I'm really happy to have you here. Thanks.
Anytime I can help out, it's awesome. Well, you've got Scott here, so wherever Scott goes, I just tag along.
Okay. Dr. Ian O'Neill from Discovery News. He runs the space blogs there. Hi, Ian.
How you doing, Tony?
I'm doing great. Welcome. It's good to have you here, as always, to get your perspective on astronomy and what is awesome. And Michael Habib from... Hold on, he's not coming up. Uh-oh. Michael Habib is a professor from the University of Southern California. His feed has sort of dropped out a little bit. I don't know if you can hear me. Can you hear me, Michael?
That's because he's in Baltimore and he froze from the temperature.
He's probably frozen, right?
Yeah.
Right, the bandwidth. And my good friend Scott Lewis from KnowTheCosmos.com. He also helps me a lot in DeepAstronomy.com. So welcome, Scott.
Hello, Tony. How's it going?
I'm doing great. Okay, so that's the people who are going to help us understand and put in perspective the year in astronomy 2013. And before we get going on to this, I'm going to have Scott tell you a little bit about how you can interact with us. Go for it, Scott.
So you need to have extrasensory perception and feed it right into my we're using this new fangled awesomeness that we'll be using the live YouTube stream. So we've generated this URL a week ahead of time. So what you're watching this now, we're checking those comments on YouTube. We've also created a Google event, so you can actually use Google+. We also have that event embedded. So if you want to share any pictures or streams like that, you can put them in Google+. And we'll be using the hashtag TYIA13, so this year in astronomy 13, on Twitter. So feel free to tweet us and let us know what you think are the biggest events that happened this year. And if I like them, because I'm kind of mean, I might like them, I might not. But if there's something really good, please let us know, and we'll be able to share it out in the live stream.
Yeah, we'll just sort of interrupt the broadcast a little bit here and there with some of your thoughts and questions. Well, so there has already been quite a few on the Google Plus event page, as well as some on the comments on the live event page as well. So that's been kind of cool. So before we get to specific things and events and discoveries that have happened in 2013, I want to talk a little bit about the big picture. And we started to get into this a little bit in the green room before I hit the start broadcast button. But and you guys were starting to argue with me, so I expect you guys to have some differing opinions. But I made, back in Space Fan News number 120, I did a commentary toward the end and I called it the golden age of astronomy, where I made the contention or the argument that I believe that the present day, this year, this decade, is among the most exciting times we have ever had in astronomy in terms of astronomical discoveries, the technologies we're using, the things that we're learning about our universe and our place in it has never been more exciting. And I'd like to get your thoughts on this, because I even think that we're learning more things with the advent with the discovery and the theories of dark energy and dark matter, the acceleration of the universe. We are learning more about our place in the universe at a greater rate and at a greater number of discoveries than I think it's unprecedented in history, and I'm including back in the early 1900s when Hubble discovered that the galaxies were all going away from one another, that there were even more galaxies besides our own, because it's important to remember that even just 100 years ago, or maybe a little more than that now, we weren't sure there were other galaxies besides the Milky Way. So we've really not only come a long way in 100 years, but I think that now is the golden age. It's never been better. So let me get your thoughts on that. And let's start with you, Fraser. What do you think of that?
Yeah, I'm going to be your total supporter. So I 100% agree with you that it is absolutely a golden age of astronomy. It's unbelievable the amount of science that's pouring out. And I've been doing this it's going to be my 15th anniversary coming up in March for publishing Universe Today. And so when I first started, I was lucky if I could scrape together 4 interesting stories a day that and a lot of them were like, this mission has been changed. And now just so many planets and so much new discoveries in every single field. It's amazing. Yeah, I 100% agree with you. There's never been a time where there have been more spacecraft out there, more missions, more programs, and more discoveries, and just these amazing communication tools that are all coming around together with the internet, just allowing all these people to collaborate faster and faster. It's a great time to be doing this.
That's a good point. You brought up another good point with just the sheer number of not only the space telescopes that we've got, but the ground-based telescopes that are online right now. And I'm not even talking about the ones that are slated for the future, like the 30-meter telescope or LSST or any of that stuff. I'm talking about the ones that are working right now. It's just unprecedented in our history. Alberto, give us your thoughts on that. What do you think?
I actually, despite what I said before in the green room, I think I kind of agree.
Oh, now you're going to be nice.
I'm not going to convince him. I'm not going to change it. I'm going to put it into a larger perspective. I think you're actually right in a sense that I like to look at an even larger picture. Take a look at science in general. Statistics. All the push for big data over the last 5 years. Take a look at computer science. Take a look at our ability to produce detectors that are extremely sensitive and are extremely large, right? That's, I think, what has been changing astronomy over the last 30 years.
We're watching the accelerated expansion of Alberto's universe right here live
something
on
like that.
YouTube.
Yeah, something like that, right? No, but I think it's all science that is. I'm not saying it's exploding, but it's really accelerating at an increasing pace. And I think Fraser touched on a good point, which is the fact that he called it the internet, but it's really the pervasive use of information technology and information in general, the way we share information, the way we manipulate information, the way we can take information we have already and translate it into new sets of information that give us perhaps new insight. That, I think, has made a tremendous, tremendous difference in the way astronomy is done, and therefore in the number of studies and discoveries. So I think it's true. We have better detectors, we have better telescopes, we have better instruments, but we also have the ability to actually analyze that data, which is a non-trivial argument, if you want to make that argument. So.
Yeah, and I don't know if this is the right way to think of it, but the way I think of it is that the degree of the paradigm shift that has happened, let's say since Hubble's time, back when he found that not only were there other galaxies out there, but they were all speeding away from us at these great speeds. The amount that our mind or our sense of our place in the universe had expanded was less than it is now, because now, and we're going to talk about some of these discoveries, the number of exoplanets the number of planets that are out in the not only our galaxy but in the universe, the fact that the universe is not just expanding but accelerating, the degree to which our minds are being here, I think, is even greater than before. Ian, you have an opportunity in your spot as the editor of a big space news organization. What is your sense of this? Do you have any? What's your perspective on?
Yeah, I totally agree with what you guys are saying. I mean, we're reaching a point where the technology is just catching up with our ingenuity. It's almost like if you gave a scientist an infinite tool set, they're able to build a telescope that's going to fit their needs. It was like recently I wrote about this telescope that's this spectrometer and instrumentation has been set up to actually observe the individual stars in a binary system, and the astronomers were saying that soon we're going to be able to use this instrument to actually resolve individual exoplanets around the star. And they say this as if it's a matter of fact. It's going to happen. But with this certainty is a very interesting thing for me, because it's only done through this crossroads. We're coming to this crossroads in like our ability to do things, and the technology is catching up. And we're seeing it in certainly in rocket science. We're seeing these cheaper rockets being launched. We're able to access space cheaper. And the same thing goes for technology. You've got amateur astronomers out there who are doing mind-boggling stuff with off-the-shelf technology. And some of the stuff that I write about are actually done by amateur astronomers. And I don't think that's always been the case. Yep. It's just now the price of this technology is being driven down. Whether you're an astronomer or whether you're a rocket scientist, it's pretty much the same thing. We're just doing more stuff, and we're able to access this technology to actually enable us to do this. Because when I was in science, when I was a researcher, I couldn't even dream, and this was only, 10 years ago, I couldn't even dream of half the things they're doing in solar physics these days. Some of the incredible imagery we're seeing from the Solar Dynamics Observatory and all the solar observatories, the incredible definition we're seeing is just incredible. And I just think that scientists have been given this, if funding allows, obviously, but they are given this fantastic opportunity to do things way beyond what we've ever been able to do, done before, really. So, yeah, so from my point of view in the media, it's just amazing. Every single field just seems to be, every single day, are bringing out new advances. There's always a big surprise. There's always an embargo piece of news that I'm just going, oh, I can't believe I know this. Just being in my position, sometimes you have a week ahead of time before the news is actually going to break, especially from Hubble. When you hear about upcoming news in Nature or Science, and Hubble, this old telescope now, is doing this groundbreaking stuff, because not only is the technology good, the techniques that astronomers are using and realizing that we can use these technologies for, is just, I don't know. It defies words, to be honest. I have a very hard time writing all these things, trying to encapsulate my enthusiasm.
But and adding to that, I think that's actually exactly the point. Adding to that, there are people that are dreaming about technologies that, for larger telescope like JWST, that when they started thinking, they didn't even exist. Because they were empowered by the fact that you're right. You talk to people, they know they're going to do things, right? And you think, yeah, this is not going to happen. And then, in 5 years, 10 years, the technology are like normal technologies, things that we all take for granted, which I think that's mind-boggling.
Well, I think,
that's
too,
a slightly different take. Oh, go ahead.
Well, I think on it, too, you have this problem of we have too much data from all of these observatories. We have too much information and not enough scientists to go through it. That's such a terrible, terrible problem to have. But then we're having.
It's also an important problem we better solve, or we're going to miss a lot of important science.
Exactly, so we have so much information that we can go through, and that's, when you're looking at it, we had to create new technologies just to be able to observe it. Now we have these observational tools that are getting better and better and better. Now we have to find better ways of going through that information we're actually gathering, so we can understand what's going on out there.
Well, you've touched on something that's related to actually one of the big stories this year, which is when the Kepler Space Telescope went down, its momentum wheels failed. Earlier this year, people were sad that it happened. We were all sad that the telescope couldn't do its primary mission, but it had already, or it couldn't continue its primary mission, but it had already completed successfully what it was sent out to do. And the data that it took were so great, the amount of data that it took, there was just going through it, the discoveries are only now starting to unroll, even though the telescope itself isn't able to do what it was designed to do anymore. So that's part of that. And to touch on what Alberto said, which and design something like the JWST, the James Webb Space Telescope, and then go, well, it's going to have this mirror that unfolds. It's going to have these heat shields that are going to get the telescope down to these really cold temperatures. And then the engineers, and then you ask the engineers, you go, well, how are you going to do it? And they go, I don't know. We don't have the stuff yet. We're going to have to invent it. I mean, that is the engineering equivalent to the scientific discoveries that the astronomers are getting from the data that these instruments take. So these are all really important points. I want to get Brian in on this just a little bit. Brian, if I recall, and this is my first hangout with you, so please forgive me if I misstate something, but I believe I saw biology associated with your name at some point. Or do you look at things in biology, or did I get that?
No.
That's Michael.
That's me.
Oh,
Yeah.
it's Michael. Sorry. Okay,
Yeah.
Michael. And then
No, I don't do biology.
I'll ask you this question. Okay. I'm sorry about that. Yeah. So,
that's fine.
Brian, why don't you give us your input on some of these topics?
I think part of it, with the data, if you say it's the golden age of astronomy, I don't think we're there yet. I think if you draw an analogy with biology in the early 1800s, it's all data gathering, and with the ships going out from Europe, you were finally getting exposure to a whole range of living organisms that we had never seen before. And in astronomy, we have the same type of analogy. We're finally getting data on things that we've never seen before. We haven't done synthesis, though. We haven't done the data analysis, though. We're just getting started on that. So I think the real golden age is going to be 10 years or 20 years down the line when we start doing real synthesis.
So you're saying that I'm jumping the gun just a little bit, getting a little ahead of myself.
The best is yet to come, Tony.
The best is yet to come.
The best is yet to come.
I won't argue with that. Okay, Michael. So
Yes.
I guess I would like your perspective from what Brian just said on the biology comment. What do you think of that?
Well, I can definitely see the analogy, and then to some extent, then it depends a little bit on what you consider to be the golden age. One could say that the golden age for a lot of these sciences is when you really start to get into all those data you develop, but one could also say that the golden age really began when you entered the realm of big data. And I could say as a biologist kind of looking in, from the outside looking in a little bit, 10 years ago, or 20 years ago, if you'd said, oh yeah, astronomy is going to be one of the next big data kinds of sciences, might have been slightly skeptical. And it's something that's been happening in biology as well. And it's very cool to see that occur. I think the analogy is there not only to the original sort of observational natural sciences that Brian was talking about, hundreds of years ago, or 100 years ago, 200 years ago, depending on which phase you're talking about, exist, but also really in parallel at the moment. I mean, because biologists have the same quote unquote problem, as Scott was joking about earlier, that you all have in astronomy and related sciences, which is you actually don't have enough scientists to work with the body of data that you have in many cases, because you suddenly have this deluge that you don't know what to do with. In that sense, I think Brian has a point that maybe we're going to see even bigger discoveries going down the line, but I think that those discoveries are going to, there's going to be I think it's going to be a very direct understanding that this was the moment when a lot of those became possible, even if one decides to define the wave of discoveries that comes in the next 20 years as perhaps being more of a golden age, as Brian is predicting.
Well, so let me clarify it just a little bit. Then I would say that one characteristic of a golden age, and then we're going to get on to some specific discoveries here, and we'll get off this topic. But I just say, to me, one characteristic of a golden age is the ability to get data to some of these outlandish theories. We have never had a shortage of theories or theorists or ideas of how the universe could be. Remember back in George Gamow's time, there was the steady state, and there was this oscillating universe and the Big Bang. All these were competing, and Gamow hated the Big Bang idea, and so did Hoyle. So but there was no real data to say which one was right until many years later, and now we can come up with something as outlandish as dark energy and dark matter. We don't know what it is. It doesn't interact with us in any way at all. None of our senses can detect it. The only way we know any of this stuff is there is that the universe is accelerating. That's for dark energy, and that we can see the effect dark matter has on its surroundings, and we can use it for lensing and things like that. So, but now we have data that we can apply to these theories and say, you know what, that theory is no good anymore. This one works because we have observations. So let me say, this is the golden age of observational astronomy. At least it's the very forefront of it. And it sounds like for the most part, we're all on the same page on that. So that's kind of cool. So let's get to some specifics. And I want to start with you, Alberto, since I want to get you talking again. I haven't seen you in so long. It's good to see your face.
Oh crap!
What would you say? What does 2013 sort of mean for you? What do you have in your mind about some of the outstanding things?
I have a couple of things. I mean, when I sent my little list to Scott to tell him what I thought was relevant this year,
Yeah,
I was going to.
list.
Well, it's not little.
pages.
It's a very long list, but,
Yeah, it was awesome.
it's a list of things that I thought were kind of important and everything. And then I realized that I was making the list this afternoon that the title of the list should have really been the year of exoplanets. I mean, we have learned that there are billions of other worlds that we didn't even know existed, just 10 years ago, basically, right? And their numbers are staggering. Like, I'm not surprised the numbers are staggering because every time we look, the universe is so large that the numbers are large, and so I'm not too surprised about that. I'm just surprised that we can even quantify those numbers. I think so. So the biggest headline, if you will, from the year is that astronomy discovered that there are 400 billion planets, exoplanets. I mean, in our galaxy alone, and 17 billion of those might be even Earth-sized, for example. So I think that is something dramatic, and I think that dramatic acceleration in discoveries has been aided by satellites like Kepler. That as you mentioned before, it's not operating any more optimally. It's still operating, but it's not optimally operating. But it actually did revolutionize how our perception of what of this. It did a sort of a census in a small area of the sky of what kind of planets we expect and to find, and we find actually, I would actually say more than we bargained for, figuring out exactly how, which is actually in astronomy, actually I shouldn't say this just in astronomy, I think in all sciences, right now that we have so much data, as you mentioned before, we do find that there are many more things that we didn't know existed, many more things that are behaving slightly differently, many more things we can understand why they're behaving the way they're behaving, and I think exoplanets is no different. And then the last thing I want to mention on the exoplanet thing is the fact that people are coming up with incredibly clever ways to detect what even 3 years ago was thought to be impossible. These Earth-sized planets. And there's a recent paper by Sarah Seeger and her student that demonstrate basically a new technique to measure the mass of an exoplanet just by looking at the transit, which again, that's mind-boggling, and it's fascinating. And again, it's proof that once you have that data, you can dream bigger, right? You can think bigger, and you can just say,
excellent point.
And I loved how they found this out, though. What blew my mind out when I did the Space Fan News on that is they use an 18th century derivation to use this to, like, we've had this all along. We just needed the tools to look at the light to be able to use this thing from the 18th century, and that just blew my mind. We've had this ability all along. We just needed to look at the right place.
So actually, that's a good point. Which is, here's the exercise for the future astronomers, for the astronomers of the future. Right, go back and read papers that were written 50 years ago that said something was impossible to do, was extremely hard, and figured out maybe there's a way to do it now. And actually, I bet that there are many techniques that can be applied right now just because we have the data that can discover that. We have the facilities that can do that. And that's mind-boggling because our ability to dream has been always very big as humans in general. You dream bigger, right, to dream about new things. Sometimes the technology hasn't kept up with us. And now technology is starting to keep up, which is kind of great.
Right.
Yeah. The year of the exoplanet, I like that. And I guess I would agree with that too. One, the discovery that we have on average about one planet around every single star in the Milky Way galaxy is to me one of those things that really help us understand our place in the universe, and so that was an important discovery. Fraser, you've been doing this for 15 some odd years. What do you think? Do you agree with that statement as far as the number of exoplanet stories that came out this year, or would that be one of the more important themes for the year?
Well, I mean, we're all huge fans of exoplanets, but I feel like we're in the middle stage. We're waiting for the big find, which is that holy grail, where we find that habitable planet, in Earth-sized world in the habitable zone of a sun-like star, and that I think we're just right on the cusp. I thought it was going to happen in 2013. I'll bet you it's going to happen in 2014. That data, I feel pretty confident, by guessing, is in there somewhere in that category. There's so many planets.
Do you have data to back this claim up?
No data. No. But you
just
know,
gonna roll enough dice.
shifty glances from planetary scientists. But I think that no, I mean I think so. I think there's been some tremendous discoveries, but it feels like we're still just circling that holy grail, which is to find that habitable world in the Earth-sized planet. So for me, I really feel like this was the year that we discovered what we've already known, but just the fact that there are space rocks hurling around and they're crashing into our atmosphere, and we need to be really aware of the risks that face us. And I think this was the year that people took it very seriously, and I think that was a big news.
That ties into the Chelyabinsk, which was on our list there with it. And what I loved after, and I'll talk about Chelyabinsk in a second, but what I loved is after it happened, do you remember all the meteor sightings that are happening all over the world?
Yep.
Because you're looking up. You're finally looking up, and holy crap, we're being pummeled with rocks all the time.
Yeah. People are like, "There's more. They're happening more often.
Yeah.
We're in the middle. We're being under siege."
Yeah, like
No,
where's Bruce Willis? We
more.
need to send him up with a nuke. You're like, no, this is just happening all the
I think what
time.
it's shown us.
Wait a second, I see them now that I'm looking for them.
Yeah, and I was relating this story earlier. We did this in the Weekly Space Hangout, but just with the Chelyabinsk meteor, right? Just imagine the fact that suddenly we have all of these dashboard cameras in Russia, and all these people are driving around, constantly viewing out the front, and then you get this incredible meteor that streaks across the sky, and you get all these different views of it from all these different dash cams. I mean, we learned there are dangerous space rocks out there smashing to the atmosphere, and Russians have these cameras everywhere.
That was the big surprise for me. It was like, wow, what are all these webcams doing on cars out there? And I love it when they had the ones that would cut to like the radio station that was playing at the time, and they're like, they're kind of rocking out to some music, and then all of this meteor that's streaking across the sky.
And how at least half of them didn't even flinch.
Yeah, they're
they're pretty
This guy keeps going.
Yeah, Russians are pretty inflammable. It's like, well, okay.
Well, I've got the video queued up. I'll share it over.
Go ahead.
In case you guys
for Scott.
see it, this is what was going on.
So here we go. Yeah, this is what dashboard cams across Russia caught.
And there's not going to be any audio, but just imagine in about 5 minutes, because there's a sonic boom.
Yeah.
All right, so this was a pretty big deal. This was early in the year, and it really got people thinking. Like Fraser said, it got people thinking about the fact that
being woken up so early.
And actually, I think to underscore Fraser's point, I think I wrote in my list because I found it as well I think we discovered like the 10,000th near-Earth object, for example, this year. So people are getting aware that we're surrounded by a lot of rocks.
And we know now who to call. The UN has got a special group that will cater for this kind of eventuality. If an astronomer discovered an asteroid coming our way, you phone the UN. Don't phone NASA. Phone the UN.
From the UN.
Yeah, because NASA would just send up oil riggers.
Yeah, everybody scrambled after the event, and then there was committees, and people gave presentations, and people started to take it seriously. I mean, they're going to forget that they took it seriously, and it'll all happen again. But at least for a moment there, the world was very interested in the risk that we face from space rocks.
Well, we're gonna hear about this again in 2026 or 2029 when Apophis gets closer to. This isn't over. It's gonna get another hype with that goes.
But I guess sorry, I was going to say just one more thing about what Fraser was saying. I was actually thinking the other day, what if this this is gone on in somewhere in Russia in a kind of a not very well populated area. What if this happens over a very large U.S. city, for example, right? And the sonic boom destroys it. So I think that's a good way to get funding. I was thinking the other day.
We need an international dash cam system.
What are you saying? We only have 7.1 billion people on the planet. A couple can die, and we can get some better space funding.
No, nobody died. But I'm saying that the awareness was dramatic just by this event filmed by Dashboard. But when large parts of the population and large cities sees this, I don't think they will forget. That's what I'm trying to say, Fraser.
What I love about, you were talking about the dash cams and it being in that populated area, is they were able to find GPS and looking at the trajectory within, I think, 36 hours. They were able to find out the speed, where this was coming from just by looking at the trajectory of this object going through the atmosphere, just because we were observing. Because people happen to be looking forward, but looking up, and that's what happens when you're looking. You're going to find some sort of data out there, and that's a big thing when it comes to science. Like, well, if you don't look, you're not going to find it.
You talk about data mining, and I think this meteor is a great example of social media astronomy.
Yep.
Yeah.
Because that's where we got the data.
Right. That's true. That's true. And
so basically, as one of my friends says, just keep looking up.
Oh yeah, I wonder who says that.
Some jerk.
Yeah,
I know.
some guy who stole that tagline from Jack Horkheimer. Yeah. Okay, well, let's stay in the solar system for a minute and let's talk about this comet of the century. Was that a big deal? Was that a big deal to anybody? Should we even talk about it?
The universe owes me a comet.
Yeah, exactly. That's exactly how I feel, Fraser.
The universe owes Fraser a comet, and YouTube owes us an apology. I can't tell you all the crap we've dealt with about ISON and about how it's.
I know. I know. At the Institute, we decided because the Hubble was going to observe it several times. We decided just to really get involved in talking about Comet ISON because we wanted to. We started a blog on it, and I made some videos on it and put it on the Hubble Space Telescope channel. So we were gearing up. This was back in July for the Comet of the Century, and it was, as time went on, looking like not so much. But so we spent a lot of time, and Hubble actually spent a lot of time. And I'll tell you, here's what I got out of the whole Comet ISON experience. We had a Hubble hangout on it, and a lot of people watched it, and I learned about other. I hesitate to call them theories, but ideas on what the comet was, and we actually got accused of. We had Max up there, Max Muster, the guy who processes Hubble data. We had him up there showing us raw Hubble data and the artifacts, and he pointed out what all of them were. We even did blog posts on what the artifacts were. This is not a spaceship. This is an artifact of a cosmic ray that wasn't properly removed because we only took 1 or 2 exposures and 2 filters, and so there wasn't enough to remove all the artifacts. And still, we got inundated with.
Yeah, you would say that.
Say comments, but they were Anyway, that was a real eye-opening experience for me, and one of the first times that had ever happened. So Comet ISON happened, folks.
But I think it taught us. From the scientific point of view, it taught us. I think a few things. And one of the most important things is that science also works because sometimes you make predictions and they don't fit. Because perhaps your models are not very good. Perhaps you don't understand. In this case, perhaps we don't understand exactly what the composition of Comet ISON was, and therefore it was just blown away by the sun's gravity and just by tidal forces. And so I think it was a boo because everybody, like Fraser said, we want a comet, we want a great thing streaking across the sky. Everybody does that. But at the same time, he actually taught us that the data that we have, I guess, on the solar system and these objects is probably not enough for us to make accurate models of what these objects look like, which is actually interesting in itself.
That's true. So while we're on the topic, before we leave I want to take a quick step back to the Earth-sized comment that Fraser said. We have a question here from Robert Klauka on the YouTube channel. Why is Earth-sized so important? You want to comment on that, Fraser, real quick, because it was in response to something you had said.
Oh, with extrasolar planets.
Yes.
Yeah. Well, this is the fuel for all of our science fiction movies and television shows and books that we've been reading. The goal here is to at least start to try and find alien life like we know it. And the first step of that is going to be to find a place that has roughly the size and consistency of Earth, that it's going to have it's going to be in the habitable zone where you're going to have liquid water on the surface of the planet that can then help support life. So, really, this is the stepping stone to us to start searching for life. That's the first holy grail. The second holy grail, of course, is going to be when we actually can detect the life. We can detect, for example, the gases of life in the atmosphere of these Earth-sized worlds. But this is this first step, and we want to find another Earth. This is one of the most haunting questions that we have as as living creatures in this universe is where is everybody else? And so far we haven't been able to find any other life forms in this entire universe. And
I don't want to be
so
alone anymore.
yeah, and so
you can come back to LA and I'll give you a hug. All right.
And so that first step, right, is that we want to say, because we have the aliens aren't here, the signals aren't being sent to us. That first step is we want to say, okay, well then if they're not going to come and visit us, then we're going to have to go and find them. And that first step is let's find another Earth. Now it might not be another Earth, might not be anything like Earth, but that's where we're going to start. And then as we get better and better and better, we're going to refine our techniques, and we are literally going to start finding other planets that will resemble Earth. And we're going to have techniques to see if there is actually living creatures on those other planets. And this is just these steps forward that we're making. So,
right. So in that sense, I guess we have not... Oh, sorry, go ahead, Ian. Go ahead.
Oh, no, it's okay. You go first. I'll go after you.
No, I talk too much. Go.
I was just going to agree with Fraser. I mean, with, it's the hunt for extrasolar planets, particularly Earth-sized ones that perhaps have a similar composition of atmosphere as Earth in the habitable zone around their star, a sun-like star. Because, of course, we only know of one planet that's got life, and that's us. So we're looking for a analog of us.
And man,
that's
is it a disappointment. It's disappointing some days.
But can you imagine? I mean, if we did find that world, even if we just had a hint that there was a second Earth out there, wouldn't that be a wonderful uniting goal for mankind? Because we've got a habit of not getting along. I mean, our national borders mean everything to us. Our economy means everything to us. We have all these wars. We all have all this bullshit that comes with being human. Wouldn't it be amazing to see that goal? It does not necessarily get in contact with a civilization. I'm sure we'd unify very, very quick if we had an aggressive alien race coming towards us. I'm sure we'd get along very, very quickly. But in the case of looking for a second Earth, if we found that second Earth, I just wonder what will happen to humanity as a whole. I wonder what will happen to us as a society. Will we come together, or will we start inventing new religions to explain this world? Who knows? But I just think that would be our best hope for unity worldwide.
Yeah, it would be one of the key. It would be definitely a tipping point for the human race to
And
see once that discovery was made.
And we'd all become Earthicans, just like on Futurama, and that would be great.
One vote there.
And I can really say I don't want to live on this planet anymore and fly off. And
Right.
Okay, we got a lot more to talk about, so I want to move on. Michael Ziegelman actually points out one of the stories on the YouTube channel. He goes, I feel like Europa is more interesting to biologists at this point, and this was actually on my list. Earlier this year, they had found evidence of what appeared to be water plumes that had come out of the moon Europa. And here is one of the coolest artist conceptions I've seen of this. This is like an amazing image. You see Europa in the foreground with a plume of water breaking through the ice, and Jupiter in the background. And that just to me is a gorgeous. It's an artist representation, obviously, but I just think that's great. So to me, this was pretty huge, and I have to tell you a little behind-the-scenes story on this. We were working. I go to the weekly press meetings at the Institute, and this was not even on our radar. And the guys at Southwest Research Institute who were going to the AGU, I guess they decided, or somebody had decided, they didn't want to go with the story, and so Ray Villard had took it, and in a matter of a couple of days had that press release up, and it was really, really well read. One of the more highly distributed press releases we did of the year. So this story makes my list, and which is I don't generally live in the solar system all that much as far as my interests go, but this was one of the ones I felt was one of the more interesting discoveries. What do you guys think?
There's jellyfish there. There are jellyfish, and we need to send a mission immediately.
To me, that comes back to what I think Brian was mentioning at the beginning, which is maybe we're maybe we're not in the golden age of astronomy, or at least in trying to find life for exoplanets, because we don't have that much data right now. So the way I really think this is cool is the fact that Hubble looks at the plumes and then he finds water, water vapor in this plume, which is fantastic. And then my immediate thought is, can you imagine what we could do with JWST in 2018 when we're actually going to do exactly the same experiment, if we will, except through the atmosphere of an exoplanet, and going to find water on an exoplanet which is many, many more light years away than the moon of Jupiter. So it's very fascinating, because I think it's true that in some area we're just scratching the surface.
I would say, from the perspective of a biologist, that Europa is probably more interesting to a lot of us than any of the other bodies in the system. Unless you're a paleontologist, which I largely am, in which case Mars is the most interesting. But it's sort of. But for those who work on living stuff, I mean, I think an environment like that is probably most interesting. I just figured I'd chime that in, since I think your listener had noted that specifically in the question.
Yeah. So okay, I'm gonna stick with the solar system, and then I'm gonna stop giving picks, and I'm gonna let you guys start doing it. But to me, an underreported story this year was this one, that in speaking of Mars, and I don't know why I am just doing solar system things, but earlier this year, back in August, I guess, according to this press release, this image was taken, and I felt like this was really underreported. Curiosity, sitting on the Martian surface, looks up, and sees this. Do you guys want to describe what that is? Anybody know?
Phobos,
that's Phobos.
That is Phobos passing in front of the
title
from Mars. And to me, this is a remarkable photo. The fact that they were able to get this at all. So that makes my list also. This news item.
That's a good point.
Well, and I love it too, because it's something where we're watching the transit of another body on our star from a completely different planet.
Right.
And that's just fantastic. I mean, we've done stuff here on Google Plus with the transit of Venus and eclipses, but when we're watching another moon from another planet transit the disk of our sun, that's amazing that we're able to do that, especially since it just got there. We just sent Curiosity there, and let's just have them aim up for a second and take a look at the moon going across. It's not there for any optical observation of the heavens at all, but it decided just to poke its head up and take some pictures while it was at it. Because doing selfies wasn't enough for Curiosity. It did have
I know, yeah, I'm getting a little tired of selfies. And to be fair, the Curiosity did try to look at ISON as well, in much the same manner. The camera was nowhere near sensitive enough to do it. And there was a lot of uproar at the time over why didn't Curiosity see it, and maybe there was some kind of conspiracy involved there. But it did try to look at it, but there was no signal. It wasn't strong enough to see. Okay, you guys, I want to hear some ideas. Who wants to go? Pick one of your favorite stories. Go, Fraser.
All right. Well, speaking of selfies, I'm going to share a picture here.
Okay.
If you guys recall this picture.
Is it of you, really?
Yeah, it's a selfie. It's me.
It's all bald. You look like Scott.
That's a compliment.
Through?
It is a compliment.
Yes,
of course. I'm getting that way.
Oh, yeah. Nice. Nice selfie.
Yeah. So for anyone who wasn't part of this was a photograph that the Cassini spacecraft took of Saturn, and while it was at it also captured Mars, Venus, and the Earth and the Moon. And what I think was really great about this story is that the folks at like Carolyn Porco and the folks with the Cassini imaging team did a really great job of letting everyone out on the internet know that this special moment was going to happen, that they encouraged everyone to take pictures of themselves with Saturn theoretically in view, Cassini, and then they took this wonderful image and shared it out, and obviously, you can't see yourself, but then they made some other great images where they actually sort of had the people. They made the version of this photograph made up of all the pictures of the people who had sent in pictures, because so many people had participated, and it really just demonstrated there you are. It's like that Carl Sagan quote that everything you know is just there in that one little dot, that one pixel on the screen. That's Earth. That's us. And I think it was great for Cassini to be able to recreate the pale blue dot image in the rings of Saturn. So I think this for me this was a great image and a really great moment in planetary astronomy.
Right.
Like it adds so much perspective.
Yeah, good choice.
Actually, nice. I wanted to add one thing. I just looked it up. I didn't realize that Cassini next year is going to celebrate the 10th year anniversary of being around Saturn. And to me, I mean, at least to me, I mean, and again, I'm not a planetary scientist, but I think Cassini has been one of the most revolutionary missions, you know, around another body. I mean, the images that it produces, the knowledge. I don't know if you guys have ever seen these images where moons perturb the rings of Saturn. I mean, those are absolutely fascinating. So it has been an instrument that's been there for 10 years, again, giving us, back to the theme we had at the beginning, lots and lots of data about Saturn, which I think is spectacular.
I think that relates to this image. You know, we look at this image and the common view is that it makes us so tiny. And I think people forget often that we're the ones who built the camera that takes the picture.
Yeah.
We're doing observational astronomy on another planet. We're detecting worlds around other stars. In some ways, it should really make us feel very mighty and not tiny.
Yeah, that's a good way to look. That's a good point. We're about ankle deep on the shores of the cosmic ocean, I guess, and we're getting out.
Ankle deep.
That's
a good one.
Out there.
I love how massive.
Yes, maybe it is.
Oh, I don't know. Audio is breaking up. But it just shows how massive our imagination is and our curiosity is, that we're able to do all this. Someone had to think it up. Someone had to go out there and think, you know what? We have the ability to do this. I don't know if it's going to work. It could be a colossal failure, but we'll still learn something along the way. Let's try it. Let's turn Voyager around and have it take a picture of home. Let's have Cassini look at Saturn and watch the sun glow and all these other planets. Let's try it. And it gives us, as an entire species, this great perspective of what we're able to do in a very short period of time.
Mm-hmm.
Okay. Ian, I want to get you in on this a little bit because we're starting. I want to make sure everybody gets a chance to get something in here, and you did a poll, or not a poll? Yeah. Well, I guess it was a poll or a vote or something on the Discovery news site, and you guys actually came up with a top 10 list. What were some of your impressions of what you guys found with your polling?
Yeah, every year we run a readers poll. So this is different from a lot of other top 10 lists where, you know, the editorial staff choose what their favorite stories were. And for me personally, I would have said the Chelyabinsk meteor would have been the most popular. I thought that would be the one that would grab the most interest because it certainly generated the most traffic. I mean, it was a huge success for us. And the fact we actually covered it on the day when the meteor hit, that actually came in at number 2 when we actually put it up to a vote to our readers, because we asked our readers for their nominations for their favorite space story. And this is just favorite story, not necessarily the most scientifically significant story, not the biggest discovery. This is just what made people want to read about space. You know, what really got their fascination during that year. And we had a real turnout. I think there was about 30 to 40 nominations. Then we had to take traffic into consideration, so web traffic as well was used as a metric, and we got it down to about 18 nominations. We put up to a vote. And as it turned out, the number 1 wasn't the Chelyabinsk meteor. It was actually Voyager 1, leaving the heliopoles and entering interstellar space. And that's another thing that's kind of really captivated people's imaginations this year is interstellar travel. And I attended the Starship Congress back in August, and basically it was organized by a group of scientists and engineers they formed a group called the Icarus Interstellar. It's a non-profit group, and it's all based on interstellar studies. And these guys are very serious about sending a robotic probe to another star. They're not talking about sending one next year or the next 10 years. They're talking about 50 to 100 years' time. So these guys are thinking really, really big. And the amount of interest that one conference generated was incredible, because the year before I went to the 100-year Starship, which is actually sending humans to another star, and that's a far longer scale project. But just the fact we're talking about sending people to another star and sending a robotic mission to another star, we're talking about not necessarily all the Star Trek stuff like the warp drive. Obviously, that comes up because the warp drive would be very useful. And in fact, there's some theories that we could actually use dark energy to create this warp bubble. I mean, obviously, this is all sci-fi notions for now, but in 100 years' time, you never know. So we had all these theoretical physicists on board, and there's been a lot of chatter about that. But also, we're discussing things like nuclear pulse propulsion. I mean, that is actually a technology that's within our grasp. We detonate nuclear bombs to propel a spaceship through space, and that could be a viable means of propulsion through interstellar space. But of course, this year, a totally different means of transportation through space. Just the Voyager 1, which actually did gravitational slingshots through the solar system over 35 years. Took 35 years to actually exit the sun sphere of influence, the heliosphere, which is basically the magnetic sphere of influence around our sun, and actually escaped into interstellar space. It took 35 years to get that far, and it's another 2-3 light years to the nearest star. So I think what Voyager 1 did, and the reason why I think people jumped on it and why there's this fascination with interstellar studies, is that it really puts things in perspective. I suppose that goes back to the image of Saturn with Cassini taking a selfie of Earth as a dot in the background. It puts everything in perspective, because when you realize just how big space is, it really makes you feel not small, it makes you feel incredibly insignificant. I mean, you are just a piece of dust. But obviously, we're not. We're actually talking about these things. We're creating these wonderful machines that we're sending through space and we're reaching out to find life elsewhere in other star systems. We're looking at exoplanets elsewhere. So I just think the interstellar concept really puts everything in a nutshell, and it really gets people excited. And as I say, this Voyager 1 story, scientists, sure enough, they realized that it exited the heliopause, and I think that's probably one of the reasons why it was picked. It's our first interstellar emissary. It's our first interstellar mission, our very first of hopefully of many. So I think that's why it was so popular, and that's why I kind of like these lists, because, and I like these readers' choice lists as well, because I wouldn't have necessarily guessed that. I thought it was going to be the easier every time.
Agreed, and I want to also highlight. I presume you're the editor here, and your choice is the Higgs boson confirmed.
Yeah,
that was a big story, really big story. So I totally agree with that. That was a good pick.
It was, and that wasn't nominated, which I thought was strange. But then again, I suppose last year was really the big year, because that was the first discovery, and I think that made our number 2 in the list last year. But just the fact that it was definitely confirmed 100% this year, and the Nobel Prize was awarded to the scientists, including Peter Higgs, the namesake of Higgs boson. I just find it fascinating. That's a fascinating field for me.
Yeah, this goes back to what we were talking about earlier with the data catching up with theories. I mean, this was back in the 60s. He was talking about this. So, and now the data are starting to bear out that he was right. So, really good story on that as well. Okay, well, let me give Brian a chance here. How about you, Brian? What was your impression of the year? What was one of the bigger stories for you?
I don't know. I think Voyager crossing the heliopause is one of them. But I think, for me, it just seems like there's a lot of little things where we're starting to get hints of data. And I think we're on the cusp of some new findings in the next year. Dark matter, I think, is going to be one of the ones for next year. Mm-hmm. Just because we've got so many detectors out there, we're either going to make it or break it.
I should also point out that the Dark Energy Survey has kicked in this year. Down at I worked on that project before I started at the Institute, and they are down on the Blanco 4-meter telescope in Chile, and they are starting to take data, and hopefully they're going to be characterizing a little bit more on dark energy in the coming years as well. So that's on the horizon. Michael, can I give you a chance? What was your pick a favorite?
Pick a favorite. Well, I mean, for a personal fascination standpoint, actually, Voyager was right up there for me. Just this year, the things that kind of made me, kind of do a little internal happy dance. In terms of things that are kind of sort of scientific interest to me, as someone who's a biologist and largely a paleontologist, some of the work that I'm looking forward to, of like the MAVEN series, the Mars Atmospheric and Volatile Evolution project, that's going to be very exciting for a lot of individuals, myself included, because in fact I'm one of those folks who gets a lot of questions about, well, what kind of habitability things are we looking at and on exoplanets, and what might have been habitable here once upon a time. And I think those are very deep-seated, interesting questions, and they're the kinds of questions that got me interested in what I do. I mean, when I was a kid, those are the kinds of things that got me into what I do for a living now. So that's kind of a cool thing, not only from just a pure scientific knowledge standpoint, but also kind of a personal note.
Awesome. Okay. And Scott, before we get too much further down, let me give you a shot here. You had some ideas as well?
There's so many. Especially doing Space Fan News, you're just doing all this stuff all the time, trying to find your favorites of the week. And I have my happy, feel-good ones, but I think for hard science, what I really love was the launch of Gaia and what it's going to do. I mean, we're 1 billion stars, and we're going to have the best, most precise map.
Okay, wait, back up. Gaia just launched.
Gaia
and you
just
did the
launched.
Space Fan News on it, this last one.
Yep,
Give us a little bit of background on the mission.
So it's an ESA mission, so it launched on a Soyuz, so it's out to the L2 point is where it's heading off to right now. And
very crowded out there, isn't it?
It's about to be.
Right, there's a lot of space in space. So
there is lots of space in space. It's going to be at this great balance point of gravity on the other side of the moon from Earth, and it's going to be mapping the Milky Way. Is going to have the most precise 3D map that we have of the stars around us, on top of doing many secondary missions. But its primary mission is to map 1 billion stars, and that's fantastic. It's just amazing that, okay, yeah, we're looking out, we're seeing all these different things, we're seeing dark energy and dark matter, we're getting exoplanets. Well, let's map the neighborhood first before we decide anywhere else, before we want to go out there, and that's what they're doing. That's what the European Space Agency is doing, is going out there and getting a very well-defined, I believe they're looking in a radius of 30,000 light years to get that map, and I'm really, really excited about that. It's a 5-year mission, and I can't wait for that data to start rolling in.
It's down to magnitude 20.
Yeah.
And I think it's like 100 micro arc seconds at magnitude 20.
That's right. It's going to measure proper motion. That's
proper motion and Doppler and spectrograph.
All
of this.
Just the amount of information we'll get to know about our neighborhood is going to be amazing.
So if we had to make a prediction, I think we can predict that Gaia will rewrite textbooks on how, for example, the structure of the Milky Way, or we're going to find some interesting trends in terms of motion and therefore infer something about the formation of the Milky Way itself.
I think
the next several years, Gaia is going to be huge.
Yep.
And then once it's done with its primary mission, then JWST will go up there and look in the near infrared and back it up.
Right. Yeah, so JWST's got us all waiting for sure.
Yeah.
Okay, well, while we're on the theme of looking ahead, and Scott, if you could do me a favor while I do this, can you line up a couple questions for us and see if because it's getting late in the thing here. But for me, I guess looking forward, what just started this year was a Hubble 3-year program called Frontier Fields, which is going to be not just. So we all know about the Hubble Deep Field. We all know what a great image that is. And for me, I still regard the original Hubble Deep Field as the most important image ever taken. And we took another one again in 2003, 2004 time scale where they call it the Ultra Deep Field. They looked at a different patch of sky and they stared at it for 11 days and they saw an image full of galaxies. Every single dot, smudge, and smear was an entire galaxy. And now the frontier, but the question remains, is the entire universe like that? If we look anywhere else in the sky, are we going to see something similar? And the Frontier Fields program is going to be trying to answer that question. It's going to be looking at 20. It's going to be making 10 more ultra deep fields in different parts of the sky using lensed galaxy clusters, and that's a topic that we'll get into. But if you want to learn more about the frontier fields, follow me at the AAS. I'll be at the AAS, and that Tuesday, January 7th, I believe, is whatever that Tuesday is. It's devoted to frontier fields. I'll be streaming live all day long. Alberto will be with me, and we will be talking all about frontier fields. So that, to me, is an important project that started this year. Will really start making inroads and discoveries in the coming next 3 years. So that's another one that I want to put on your radar as well. So Scott, we have any questions?
We have a bunch, and I'm trying to weed through the YouTube comments and the questions. So I'm seeing a lot of people supporting Europa. So Europa is a big thing that people are saying is their favorite.
Oh, here's one.
He found one.
Yeah, Nathan Aerosmith goes, what are you guys most...
Nothing. Go for it.
What?
Nothing.
Oh, Nathan Aerosmith on YouTube goes, what are you guys most excited for in 2014? That's a good question. I just told you mine, and Scott told you his, I believe. How about you guys? You guys want to take what you're most excited for in 2014?
Gaia.
Gaia for you too? Okay.
The fact that it's up there, what it's going to find.
Okay, so I think that's the consensus. What about you, Alberto?
Well, I mean, I'm biased because I think I look forward that JWST is coming together, so I think I'm really excited about the program continuing. But no, but one thing that people haven't mentioned, which I thought was in my list, it was nobody mentioned because probably nobody cares, but that was my early love when I was doing active astronomy, I guess. It's galaxy formation. So we found the farthest galaxy to date, right?
Yeah, that's right.
So I guess it doesn't capture the imagination as as images of solar system, but it's an interesting benchmark because we're basically throwing darts out there and taking a look at what's really out there, and then sort of examining the very, very early universe and prepping the early universe, if you will, for what JWST will look at, which is, I think, very exciting from a scientific point of view. We really want to answer that question, what are the processes that generate large galaxies like our own? And I think you have to start with Hubble. We're using like frontier fields that you mentioned, using gravitational lensing as a tool to get you much further into much earlier into the universe. But then you can also look at very clever techniques to find infrared galaxies. And so, waiting for JWST, it's I'm going to say this very, very often, but it's an exciting thing. So,
what about you, Fraser? Is Gaia on your radar for 2014?
Super excited about Gaia, absolutely. But the mission that I'm actually the most interested in is Rosetta. So in November of 2014, Rosetta is going to harpoon a comet, and then it's going to drop a lander down onto the surface of the comet, and that's a first. So
that will be cool.
Yeah, and like a nice soft landing on a comet. So I'm really, really excited. I think that's going to be the story of the year. I think I'm pushing it now. So
you just remind me of something too. We landed on the moon again. We have
last year. You've missed so many.
Right. It's been such an amazing year.
I know.
Yeah, the Chinese landed on the moon. The SpaceX sent with the first private company.
I know. We didn't even get to
powered flight.
Private launches.
Of the Virgin Galactic spaceship too. Curiosity found evidence that there was water for a long period of time on the surface of Mars.
And now it's
I could go on.
Yeah.
We need a year to review the year.
Yeah,
that's right. We need a year to review the year, and that's how you know you're in the golden age, guys. Can you imagine what it's like when we really get there? I mean, it's like we're going to need a week or to make a Jerry Lewis telethon or something.
Well, I think my two favorite feel-good ones are, first of all, Space Frog. You guys remember Space Frog during the Laddie launch?
That was so sad.
That got a lot of it got a lot of people watching something going on with space, and so let me see if I can pull up that image. But it's sad for the frog. Sorry, frog. But
show some respect, Scott.
Yeah.
No.
Stop parading his dead body.
I don't know if he's dead at the time, but you know what?
That's a little bit morbid on your part, I think.
But yes, it's fine. You know what, Ian? I'm going to use it from your website. By Ian O'Neill publicly showing this carcass of this infant.
I think I did a zoom-in shot as well.
Okay. Yeah, Space Frog.
And then, honestly, Chris Hadfield, he was amazing.
Oh, the video, yes, we didn't get that.
I mean, he did so much for doing science outreach from space. And then when his crescendo before he came back to Earth was doing Space Oddity from ISS. But he did such a great outreach with students of all ages with his what's going on in space and how do things work up there.
If you haven't seen that, folks, we'll have a link to that. We won't have time to show it here, but we'll have a link to it on the video in the description box down here. There's one comment. Darn it, it keeps scrolling past, and I wanted to get to it before I let it go. But there was a comment on here. It's just here it is. Oh my God, you guys! EKS Excalibur. That's funny. EKS space CALYBUR Excalibur. Made a comment. Does NASA still plan to simply let Hubble burn up in the atmosphere when they are done with it? An instrument that crucial to human advancement should be a museum piece, even if it's kept in orbit. And the reason I want to talk about that just a little bit is that it's not as if the Hubble Space Telescope was designed to be grabbed and put in a space shuttle cargo bay, and there aren't any more space shuttle cargo bays to put it in. So it's probably going to burn up when it's done. It is in the high upper atmosphere. It does experience atmospheric drag over time, but the plan right now is that Hubble is not only going to be around it was extended from its last servicing mission, probably, the plans are, at least in the building I work in, for Hubble to be around for another 10 years. They want to have a lot of overlap with when the JWST launches. So it's not going to happen anytime soon, but I will give you one ray of hope. And you can see this on almost any Hubble image that's been taken after the last servicing mission. And I don't remember if it was in gravity or not. I should have paid more attention. But John Grunsfeld installed a black ring, a dark ring on the bottom of the Hubble Space Telescope. And it's just a ring, and it's just designed to grab it. And so the hope is, and I know John Grunsfeld thinks this way, the hope would be to grab, hopefully, a robotic spacecraft of some kind to go up, grab it, and bring it down. But it's still doing a lot of useful science. Nobody is counting Hubble out yet, but there is hope that maybe it could be brought down. It's a slim hope. We'd have to have the will to spend the money, but it is a hope nonetheless.
We should ask John on that
one. What's that?
I said we'll have to get Elon Musk on that one.
Yeah, we'll get Elon Musk on it.
Exactly.
I know Ian's talked with Elon Musk for a little bit, so maybe you can go ask him about using Dragon to bring back Hubble, or Dragon 8.0 to bring back Hubble.
Yeah, exactly.
I'll be giving a talk at Scale Composites in January. I'll see if they have anything that we can cobble together.
Yeah, see what you can do about that, please. I'd appreciate it. You've got about 10 years to get something put together.
So. They're pretty good over there. I'm sure they can come up with something in 10 years.
Yeah, I'm going to go there as well, because I guess not many people know, but Scale Composites is owned by Northrop Grumman.
Oh, it is?
Yes, and so we're looking at that. I think we're going to find that
Northrop Grumman owns a great many things.
Yeah, but that's one of the coolest things that I think they have. A really very, very interesting. It's an incredibly innovative company. It's incredibly innovative company, and they're doing incredibly innovative things, and so people are watching out for them. I'm surprised nobody mentioned that Elon Musk said that we want to go to Mars and have 30,000 people or whatever colony by 2030.
Yeah.
Well, so do I, but there wasn't any press about me saying it.
Well, Scott and I got a chance to actually visit the SpaceX factory when we were down in Los Angeles back in November.
They're making a second stage right there.
Yeah.
Amazing. They're building a second stage. We're geeking out hard.
Yeah, but you walk around and you talk to any of the engineers there, you're like, so do you think it's going to happen? Are you guys going to go to Mars? Like, oh, yes. Yeah, we're absolutely going to Mars. Elon, this is the whole point of this company, is to profitably go to Mars. Elon Musk is dead serious about going to Mars.
And I love how they were dangling the first Dragon capsule that came back as like, see, this is what we can do, guys. It's just keeping it up there, letting them know what they can accomplish. Right. And Dragon was huge, and being able to go up and service the ISS is just proof that they can do it. And I do think that SpaceX is going to be huge in getting us back into space.
Into manned space.
Yes.
Yeah.
Humans.
We're all shaking our
Right.
heads in acknowledging that we all agree with that. Yep.
Yeah. Well, on that note, we've gone a little bit past an hour. I apologize, guys, I appreciate you guys staying with it. But well, you know, one of the the privileges of working in astronomy as a career is that we get to talk about and really at least I get to get paid to think about our perspective in the universe, and it's one of the few sciences, as commenters have pointed out on YouTube, where that's our primary goal, and we've mentioned it several times over the course of this hangout. The most important discoveries, the most important news stories, the ones that captured our attention the most are the ones that gave us perspective, and that's what astronomy does better than anything else. It gives us that. I mean, of all the sciences, it's one of the most awe-inspiring ones that you can enter into. Over the coming year, I'm going to be having some hangouts to talk about that. If you're interested in becoming an astronomer, I'm going to get astronomers on here to help you enter the field and to try and answer your questions and concerns about what it would be like to be an astronomer. So that's coming up in the coming year as well. As I pointed out, the next big effort I'll be doing is I'll be at the American Astronomical Society meeting all week long. I'll be streaming a variety of ways for the Hubble Space Telescope. I'm going to be experimenting like crazy. This was an experiment. Next time I'm going to be streaming on Facebook and on YouTube as well, and on G+. I'm going to try a whole bunch of different things. I've got special equipment I'm getting that is going to make sure I have bandwidth no matter what, not like last time.
I don't envy your back after that week, man.
Yeah, it's going to be interesting. So, Alberto, I hope you're ready because I'm looking forward to seeing you, and I'd like to invite some of these guys back if you guys are interested in as well. Ian, Fraser, Brian, Michael, Alberto, and Scott, thank you all so much for joining me tonight. This has been a lot of fun. I hope we can do this again next year. On behalf of all of these guys, I'm looking forward to, I hope you have an exciting and prosperous 2014. I'm looking forward to a prosperous 2014 in astronomy, full of discoveries and more groundbreaking perspectives that shift our view of our place in the universe forever. So on behalf of all the people who attended tonight, thank you very much for watching, and as always, keep looking up.
Keep looking up.
Indeed.